All right, so we've been looking at data and univariate data, and we looked at ways of displaying it, and now we are looking at ways to compare it. So last lesson, we looked at measure of center, and now we're going to start looking at, if we look at the data, we're going to look at the measure of what we call the spread. Now, I want you to put up here on your notes the measure of spread, or it can be described as the variability. Sorry, I can't really spell very well, but the variability. So, and maybe just put in brackets there. So a larger spread equals more variable. Okay, so it means like you've got lots of options because they're more spread out, or a smaller spread, we might say less variable. Now, so we need to have all these sort of wording handy, because when we're asked to compare data, you know, we might be looking at two lists or two sets of data we want to compare. We need to be able to say, all right, this data is more variable than that data because, you know, it's IQR, or we might talk about the spread. So there's a couple of measures of spread, and the first one that we can talk about is the range. So the basic range is the largest minus the smallest. Now, we'll write a little note that these values can be outliers. So we'll see it when we do maybe dot plots, or we've seen the outliers. That's still the maximum, or it's still the smallest value. So because the range includes those outliers, it's not very good. It's not resistant. It's not a very good measure of spread if there is outliers. So we don't use this one often. We would probably use the next one that we'll have a look at in a minute. But let's have a look anyway. So consider this bit got crossed off, but that was task B. It says consider the marks for two different groups of students, and we want to find the range of each distribution. So remember, the range is the max minus the minimum. So you just have to have a look through, and what is the largest for this one looks like 91, and minus the smallest, which looked like 2. Would you agree? Yeah, so we end up with this one has a range of 89. Now, if I look, that was task A, or class A. So, or task B, if we do the range here, we've got maximum minus minimum. So let's have a look through what's the highest in this data. I think 91 again. Oh, yeah, sorry. So 94 minus 2 in the first one. We missed the biggest. So let's add that one. So that's 92. So this one is 91, the second in task B. The largest, sorry. Yeah, and the smallest looks like 11. Am I correct? 11? Yeah. So 80 is the range. Excellent. All right, so there is how, and you can see if you're just given the list of data, it is quite hard to see the maximum and minimum. So when we present it like down here this is the weights of 19 cats have been in an ordered 7-leaf, it's much easier to get the range of this one because the maximum will be the last leaf, which is 64. Now, I have to be careful. It's not actually 64. The key is indicating that it's actually 6.4. And that made sense because I knew we were doing the weights of 19 cats. I'm not going to have a cat that weighs 64 kilos. That's going to be a bit of a worry. So there's things like that you should always be doing to check that what you're doing is correct. So 6.4 minus the smallest, which was 0.5. So the range for the cat's weights is actually 4.9. 5.9. Gee, I'm on a winner today. 5.9. So what we're saying is that all the cats' ranging of weight is all roughly around, they all vary around each other, 5.9 kilos. So if you like took another group and the group of cats had a range of 10 kilos, that means they're really more spread out. Like they've got some that are big and some that are small. It would vary more. Okay, if we do a histogram, if we're given a histogram and we want to get the range, we have to look where our first sort of column or tower starts. And that one's starting at 173. So that would be my minimum. And my biggest one is 187. So that's the maximum. So when we can find the range reading off that one, and we can say it's 187 minus 173, which would equal, what would that equal, 14? Okay. All right. So there's the range. Really easy to do the range. Now the next type of spread that we're going to look at is the interquartile range. So I want you to also write above this so that you don't forget. So this is it's the measure of, so let's just say it's the measure of spread as well, or we like to say variability. So it's the same. If it's larger, it's more variable. If it's smaller, it's less variable. Now, this interquartile range is also actually so the interquartile range, it's actually a resistant statistic. Oh, we've got it there, actually. We've got it. It's a resistant statistic. It's not affected by those outliers, because what we're actually doing when we do the interquartile range, say this is your whole set of data. When you find out the interquartile range, so here, this is the interquartile range. It's like the Q3 minus the Q1. What it tells you the middle 50%. It's like the range of the middle 50. And because 50% is a majority, if you tell people where the middle 50 is sitting, you're pretty much saying where most of the data is sitting. So it's more interesting and probably more effective on talking about the spread, because it doesn't take into account those outliers. All right, so we're going to learn, like we did with the median, we're going to learn how to get the interquartile range without popping the whole list into the calculator. We will do that, and I'll show you how to check. But as I said, next year in year 12, there's times where this is going to be quicker, that you know how to do it manually. So let's have a look at the rules they tell me to do the interquartile range. It says, first you got to arrange them in order from smallest to largest, and they often are displayed to us like that. So if we've got a dot plot or a histogram or a stem and leaf, they already are ordered. Now, you're going to divide the data into two equal groups. So if you think about it, just to show you, so if we divide the data in half, so this was the data, so you can see when you actually get that middle number, that's the median, and we know 50%. So what we do is we divide, if you divide the first half in half, you'd get Q1, and if you divide the second half in half, that tells you what the Q3 is. So really what you do, it's like finding the median of the first half. So if you want to write under this, so Q1 equals the median of the first half of data. And then Q3 equals the median of the second half of data. So we're going to be still doing like the same process. So, you know, you should be able to work that out. We practiced that last week, but let's give this a go. So it says find the interquartile range of the weights of 19 cats whose weights are displayed in order. So just to do a little bit of a recap, so the recap, I'm just going to go and find the median, just to help you. So for the median, remember we find the median at n plus 1 divided by 2. So in this example, it would be 19 plus 1 divided by 2, so equals the 10th. So if you count through the leaves, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the median. So that's the median. So really, all these numbers here before the median, so all these numbers here right up to before the median is the first half. So we actually have 9 numbers there. So when I go to find the, so I'm going to go find Q1. So Q1 equals median of first half. So in the first half, I actually have n equals 9. There's 9 spots. Yeah, 9 data points. So if I do n plus 1 divided by 2, so I do 9 plus 1 divided by 2, I end up with the 5th. So if I count out 1, 2, 3, 4, 5, so this one is the Q1. So Q1 equals 2.5. Okay, so we've got Q1. Now you already know, because you've split the data exactly in half, there's still 9 values that happen after that median as well. So the quick way to find the Q3, and let's just do this. So Q3 is going to be the 5th spot back from the end. So once you've found out what Q1 is, then you just go backwards. So I'm going to go 1, 2, 3, 4, 5. So there's Q3. So Q3 ends up equaling 4.8. So then when we go to get the IQR, so I'm just going to write therefore IQR, the interquartile range, is 4.8 minus 2.5, which equals 2.3. So the middle 50% of data of these 19 cats, the middle 50% range within each other by 2.3 kilos. They vary around.